Hey there, everybody. This is Deepak Kumar, and welcome back again. Now, in the last class, we were discussing about the concept of speed and velocity, and in this lecture, we are going to talk about how to find out the instantaneous or the average speed and or velocity with the help of graphs. So let's begin. Over here, what we have is a distance versus time plot for a particle which is moving, and we are interested in finding out the average speed first of all. So remember that average speed will always be calculated for a particle under a certain time slot. Like you'll be finding out the average speed for a certain time window, right? Say for example, you could be finding out the average speed of a vehicle from for 10 minutes. What was the average speed of the vehicle over the period of 10 minutes? So you'll be going for the distance traveled by the particle in 10 minutes divided by 10 minutes, right? Similarly over here as well, what we do is we need a range of time over which the average speed will be calculated. So let's say the time instances or the range of time over which I'm interested in finding out the average speed is starting from T1 to T2. All right. Now, first and the foremost thing what I have to do is find out the corresponding distances traveled by the particle during the time T1 and T2. So in order to do that, I just have to draw some lines over here. So at T1, I can see that I believe, yes. So this is the distance traveled by the particle up till time T1, and for time T2, the distance traveled is somewhere around here. Yeah. So let's mark these distances as S1 and S2. Now, in order to be able to find the average speed of the particle from time T1 to T2, what we have to do is draw a chord that joins these points. If these points are A and B, we need a line joining the points A and B. Now, the slope of this chord will tell us the slope of the average speed of the particle from time t1 to t2. Right. So once you have calculated the slope, you can just go with rise over run. Right. It's an interesting way of understanding slope. Rise over run. A friend of mine who teaches mathematics, he's there on YouTube as well, Mr. Ronak Sharma, by the name Stuck in Mathematics. He told me that you can always understand slope by this concept, rise over run. Right. Pretty interesting and very simple. So if this angle is theta and I'm interested in finding out the slope of this chord, all I have to do is go for rise over run. Now, following rise over run, I have to find out the rise, which is the y-axis, the change in y coordinate. So that will be S2 minus S1, and the run, the horizontal uh, movement or the horizontal change is T1 to T2. So rise over run. So slope will be equals to rise, which is S2 minus S1 divided by T2 minus T1. This can also be written as tan theta. Now let's move on to the next concept, which is the concept of instantaneous speed. Now remember that we are not going to focus a lot on velocity, average and instantaneous velocity, because it's pretty much the same as what we are doing here. It's the only difference will be distance will be replaced by displacement. Okay, all right. Now, having understood the concept of average speed, now let's talk about instantaneous speed. Imagine a vehicle, like the example that I gave in the last video. A vehicle is moving from 8 to 10 a.m. Let's say the distance traveled was 100 kilometers. Now, if I were to ask you the speed of the vehicle at let's say 8:35 or maybe 8:40, now precisely at that time instance, the speed of the vehicle is the instantaneous speed, right? Now, in order to find out the instantaneous speed, we need to first of all know the time at which the instantaneous speed is being asked. So let's say the time is t naught. Over here, the process is pretty simple. We need not even know the distance. We can just go with the slope, slope of slope of tangent at this point. So if I were to draw a straight line, and let's try to adjust it somehow so that it becomes slope. If I were to rotate slightly, it should be just right. Okay, that's almost there. Yep, just right. Now the slope that I've drawn here, which is the slope to the graph at t equals t naught, the slope of this graph will tell me the instantaneous speed. Instantaneous speed. Now, for those of you who already know how to differentiate and integrate, you all can follow this very simple method of finding out the instantaneous velocity. If the position is given as a function of time, it could be any polynomial function or a trigonometric function, anything, right? You could simply differentiate it with respect to time, and the next, the derivative that you're going to obtain is going to be the speed of the particle. So it's pretty simple. Like say for example, x equals to t square plus 2t plus 4. Say for example, we have this time dependent position for a particle, which means if I have to find out the position of a particle at any given time, I just have to substitute the value of time in this function. Say for example, I want to find out the position of the particle at t equal to 4 seconds. So I just put t equal to 4 over here, right? I just put x equals to 4 square plus 2 times 4 plus 4, which is 16 plus 8 plus 4, which is 28. Right? So the distance traveled by the particle in 4 seconds will be 28. Now, how do we find out the speed? Well, you just have to differentiate it with respect to time. So dx over dt equals to 2t plus 2. So as a function of time, the speed of the particle will be given as 2t plus 2. So at t equal to 0, the speed of the particle is 2 meters per second or 2 units per second, since units are not specified here. Then at t equal to 1, it will be 4. T equal to 3, it becomes 8 meters per second, and so on, right? So if you're given the graph, that's how you're going to find out the instantaneous speed at any given time instance. You just have to draw the slope at that point on the graph, and you have to draw the tangent. I'm sorry. You have to draw the tangent, and the slope of the tangent will tell you the instantaneous speed. And just to recap, for average for average speed, you'll have to find out the slope of the chord between the two timestamps t1 to t2, between which we have to find the average speed. So I hope the concept of average speed and instantaneous speed was clear. We'll see you in the next video. Thank you for joining. Goodbye.